This is Pre-Calculus, Functions and Graphs. I'm Mr. Stark. We're on the final lesson of the current unit of study. Look at all of the amazing things we've covered. Equation solving, 12 basic functions and their properties, operating on functions algebraically, understanding them numerically, and seeing them graphically. In this final lesson, we'll create a function from data using the stat feature on the TI-84 graphing calculator. It's a process we'll use in the next unit as well. You can follow along using this document. We'll start with the process followed by the steps on the calculator. Let's get started. Regression. It's usually understood as the process of modeling data, but it also includes a prediction based on past data. So what I'll do is explain the entire process, from entering the data all the way up to predicting based on the data. Here's how to construct a function from data. By the way, these steps work best with the TI-84 graphing calculator. Step 1. Enter the data using stat edit. Step 2. Create a scatter plot. We turn the plot on, then we press zoom stat. Step 3. Choose a model based on the scatter plot. The model could be linear, quadratic, cubic, a sine function, a natural log function, a power function, and even a logistic function. Those models could be chosen by pressing stat, then calc. Step 4. Calculate the function. You want to verify that the correct lists are entered and then store the regression equation. Step 5. Graph the function. Once you have the function stored in y equals and graphed, you can make predictions. I'll show you how to do all these steps on the TI-84 graphing calculator right now. So I turn my calculator on, I'm on the main screen, and I'm going to the stat button and press enter. I already have my data in here, which represents the number of patent applications from 1993 to 2002 in the United States. So I'm letting the first year, 1993, be x equals 0. And the way that I enter this data in is I simply type it in. So you could pause the video now to type in this data and work along with me. So I press 1, enter, 2, enter, 3, enter. Then I move to the right and enter the data in list 2. Enter the first value, press enter, and so on. So notice that we have L1 and L2 at the top. We could enter data in the other lists as well, but they're both sets of data, just a list of data. So we want to actually visualize this data as a scatter plot. So let's turn our plot on. Second y equals, press enter, and then press enter on the on button. Notice we have different types of graphs, but X list L1, Y list L2 shows up there. Then we could also change the marks and the color if we really wanted to. Now press zoom 9 for zoom stat. What that does is changes the window based on your data. Eventually, if we predict data, we might want to increase the window to the right, let the x's be bigger and the y's be bigger. But now we have our scatter plot. So we could choose a model based on this. So it could be linear, quadratic, cubic, and so on, like I mentioned already. In this case, it may be quadratic, but we're just going to focus on linear. So press stat, arrow right to calc to see all of those options. We're about to choose option 4, but all those other options are below there. There's LNReg, which is natural logarithm, that's not linear, exponential regression, power regression, and logistic regression. So we're choosing 4. Notice the lists show up again. List 1 is our x values, that's our years. Y list is our y values, those are the applications. And we could store the regression equation don't worry about frequency list. We could store it by pressing alpha, trace, and choosing our y function. So just choose y1. Then we press enter, enter, enter. We could also enter y1 using the bars button, by the way. So there's our information. The a is the slope, the b is the y-intercept, and because we stored that equation in y equals, we could just press graph. But if you want to see that equation, you go to y equals. So it enters it for us with lots of decimal places. Then we could simply press graph to see that, and it already has the correct window. So notice that our data is modeled quite well with that line, and if we chose a curve, it'd be really difficult to understand if those last 2 points would be modeled well. So I press trace, and you could jump between the data and the line by pressing up and down. But I want to show you what happens when you get to, like, say 10. Notice the 369.368. Then I jump up or down to the data, and I go to 10, and I see that that models it quite well. So I was jumping up and down between the data there. Now I'm looking at 11. Sometimes you could get right on the integer, sometimes not. But we have 388.598. So that's a prediction. That's the 11th year. So now I'm going to my main screen and pressing alpha trace to pull the y function out, to call on it, and plugging in 11. So I should get that same value, and I do. So notice, graph, 388.598, and then back to the main screen, 388.598. So if we want to enter the 12th year or the 20th year or 50 years from now, we can do that using the main screen. The last thing I want to show you is the diagnostic. In the catalog, which is second 0, press D, which is the x to the -1. Press diagnostic, press enter on that. And if you press enter again, it turns it on. So what that does is it allows you to see how correlated the data is with the model. So if we do this whole process again and we calculate, we can see that something new shows up, r squared and r. So that information is helpful, that r value is the correlation coefficient. And the closer that number is to 1, the more correlated the data is to the model. So sometimes questions ask for that information. What is the correlation coefficient? And that's how you get it. So you could leave that on because it doesn't hurt to actually leave it on for the rest of the time when you're working through problems. Okay, so what we did was we entered the data, we created a scatter plot, we modeled that data using a line, and then we predicted information based on that line. So we chose the 11th year. So again, you could enter any year, and that process of predicting based on data is called regression.
Hello? Oh, hey guys. I think I'm supposed to say something. Thank you for watching. And
Math rules.